The next step will be for us to implement the intarray extract function, which is meant to actually take your array, the first parameter, and create a copy of the subarray delimited by the start and end index. So there are many things that can go wrong here, starting with somebody calling our function and providing an end index that is actually past the physical end of the array that they pass. Well, this is going to be a little difficult for us to check. We could ask for another parameter. It's kind of making the interface a little easy. Instead, for this exercise, we're just going to assume that the end parameter is always going to be valid. Okay. In fact, for the sake of simplifying a little, we are going to assume also that start is going to be valid. The only thing we are going to check is whether start, for example, is actually how to say, the start index is located after the end index. So let's go to the code. Hal.h is already there, hal.c is here. So we are going to get rid, as usual, of our error situation. So for example, if end is less strict than start, we know that this is definitely a no-no. So we are going to return, I have it already here, we're going to return no. Okay, get rid of this error situation, and like I said, this is pretty much the only one that we are going to double check. Now that we can trust start and end, we are going to have to allocate dynamical memory to be able to hold all the elements between start and end. So our size for our copy array will be end minus start plus 1, which I think is actually given to you right here. Yeah, so size is end minus start plus 1. Once we have that, we can do our memory allocation. So int star p equal int array, always rely on the code that you already wrote, okay, size. And at that point, we should have our copy ready to use here. What else do we need to do? Well, we need a counter control loop to copy everything between index start and index end inside of our newly allocated array. So for, I'm going to need total index array. For I equal start, I lesser strict than end, I plus plus. And as I write this, it raises the question of whether we want start and end to be inclusive or not. Well, we're going to have to make a choice here, since it was not, I don't think the exercise was that clear about this inside of data. No, it's not clear enough, so we're going to have to make an assumption. The assumption will be, in this case, and I document it with a comment, copies everything between start, between indexes start, inclusive, and end, exclusive. Why do I choose exclusive? Well, there are good reasons for choosing either one, so it really doesn't matter. I choose it because so that somebody can pass here as end parameter size, the size of the array, and it will copy everything until size minus 1, which is correct. So that's consistent also with the lesser strict sign that I have here. So for I equals start, I lesser strict than end, I plus plus, I'm ready to make my copy. If I write p index I equal data index I, the indexing in data is fine. The indexing in p is awful. Why? Because I start with I equals start. So I want to start with I equals 0. So I'm going to just subtract the start index. And that should make my copy. When I'm done, return p, the address of the newly allocated array. And that should be it for this extract function. So I'm going to save. And first, double check for syntactical errors. Quick. Okay, syntax is okay. Now I'm moving to test.c, and I'm going to try to test this function. So I just run the intarray extract function, and I went light a little on the error detection, as you can see. So I'm going to go here, add a new function, test intarray extract, and I'm going to, as usual, now cut and paste this to make it my function signature. Add a void for good measure, and then I'm going to go ahead and implement this function. So here we go. I need to indent all of this properly. Let me just keep an eye here, group all of this, and there we go. And as the return type, void. I have now, well, I will need now an array, let's call it A1. This array will be of size, let's take something relatively big, A9, size 9. I'm going to put inside of it number 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And I'm going to try to extract something. So I'm going to prepare already my solution. A2 will be an array of size, let's say 3, containing 3, 4, 5. So I'm going to extract a subarray of length 3. How do I call this? Well, I'm going to need a pointer, and I'm going to call intarray extract. I'm going to say I want to extract from array A1, and I want to extract between indexes. So the 1 will be at index 0, 1, 2, so starting at index 2, up to index 0, 1, 2, 3, 4. 4 included, so that means 5. And then, once I get this, I'm going to start checking that everything went wrong. If not P, if P is null, printf, there was a problem. Error, int array extract, oops, little typo here, int array underscore extract, returned null. And that doesn't work in our case, right? So if I didn't get null, then I'm going to compare with result, int array compare by position. I'm going to compare A1, I'm going to compare P, with A2, size 3. And same thing here, I'm going to check if result, what do I expect? I expect true. So if result is false, I have a problem. So if not result, printf, I can indent this a little better here, printf error, int array extract, produce erroneous contents. And I'm going to stop here for the test. Once again, and this time I'll leave it definitely as an exercise. Once again, you might want to revisit the code here of intarray extract, and you might want to check things such as data being null, okay? Int start being lesser than 0. Int end, like I said, we cannot really check if it's beyond the end of the array, but we can check what we did already here. So there are a couple of little extra things here that we could do to ensure the security of the code, okay? Same thing in test.c. As you add more feature, you could check here what happened when I call with a null array, etc. So I'm first going to make sure that this works, then pause the video, and then we'll complete this. So saving, go back to Conqueror, trying to compile here. Apparently it doesn't want to compile. So yeah, there was a little delay here. So compilation went okay. Let's try to execute the code, see if any of my tests is triggered. No, everything is working fine. So I suggest you pause the video and you finish as an exercise, even if you had problem coming up with your own intarray extract, what I suggested. Well, if you are still here, that means that you need some help with this. So let's go ahead. If start lesser than 0, okay, start should never be lesser than 0, return null. If data equal null, return null. Okay, these are the two that we mentioned. Now I can save. And if you had problem coming up with this by yourself, you really need to seek some help. Contact the TA, contact your instructor to be able to get in a little discussion to try to identify exactly what was the problem in coming up with the solution by yourself, okay? Because at this point, this is becoming a routine. It should be very, very easily. So what else do we need to do now that we have those two cases as well? Well, we are going to call intarray extract, and we're going to call intarray extract so that, let me modify here the code a little, so that we trigger those error situation, okay? So namely, I'm going to start by doing an intarray extract on a null pointer, This is my null array, 2, 5, why not? And if this doesn't work, well, if not p, that is, if p is null, printf, of course, error, int array, extract, and I'm going to give information about what happened. This was null, doesn't matter. So when I call with a null array, this is what happened. And now I'm going to take this code, and I'm going to try again to call this time with a valid array, a01, but with a value here of 0. And this is going to be, I'm expecting actually null. If I get anything that else than null, problem. And then last touch, what if I call with a negative number? Okay. And there we go. Save. Let's go and compile this. Compiles okay, let's go and run it. And this time it's telling us that we have a problem with passing null and passing null and -3. Well, first this is a typo on my side because here we passed a1, so that can be confusing. So let me go and revisit this. Save, conqueror, compile. Little difficulties here getting my prompt to come back. Okay, there we go. Compilation is okay, run again. So we have a problem with null and we have a problem with -3. Weirdly enough, we don't have a problem with 0. So let's go back and make sure that we test correctly first. We have a problem with null here. We have a problem with no problem with 0, a problem with -3. Let's go back now to the code of intarray extract. Apparently there is something that was worth testing here. Let me see, if data equal null, return null. Well, that sounds about right. And if start index is lesser strict than 0, lesser strict than 0 is a problem. Equal 0 is not a problem. So that's what is wrong here. First, I should not test this because this is going to return to me a valid number. So I'm going to go ahead and get away with this. And I'm going to rethink here what I'm doing. Null, if my array is null, I'm supposed to return null. So if p is true, this is when I have my problem. Sorry about that. I inverted the logic here. So conqueror again, this time we should be all set. This is what happens when you try to do easy things too fast. And now the tests are successful, so we are pretty much good. I'm going to put back the code for extract on the screen, and we are done with this exercise.